Alrighty, let's take a look at electricity homeworks 1 and 2. Now, I'm going to focus primarily on the math questions, the multiple choice questions. Sorry, folks, you're on your own. Figure them out. If you can't figure them out, let me know. Okay, and I will help you. So these are focusing, for number 1, this means we're focusing around 8, 9, and 10 for these. So here's our first question. Let's consider what we know. We know the coulombs of charge. Right, we're going through a copper wire and we're given a current. Now keep in mind coulombs, that's Q, right? Our current, in this case, 4.9 amps, or A for amps. All right, what do we know? Well, what do we know about current? Current is how much charge per unit time. What are we looking for? Oh, we're looking for how long? We're looking for this one. Do keep in mind, we tend to have the most algebra mistakes when we're looking for something on the bottom of a fraction. So you may find it easier to work with the formula in this way instead of looking at it as an actual fraction. That way you can do the algebra correctly. Just a thought, up to you. All right, on to the next one. Here's our next one. Ion is displaced through a potential difference. Now don't be alarmed by that. Potential difference is just another way of saying voltage, right? That's our voltage. And experiences an increase in electrical potential energy. So energy or potential energy, however you want to put that. And then you are given a value. Don't forget, in this case, oh, sorry, I was looking at 71. You're probably like, 71? Where's she getting 71 from? The question we have in front of us is 60. I have a hard copy in my hand. It has different values to it. They're blurry on my screen, so it's hard for me to see. All right, but I'll try to get the numbers as accurate as I can. I do believe that's what it says on the screen. Okay, so 3.86 times 10 to the negative 17th joules. Don't forget the negative 17. That's important. Okay, and we are looking for the charge. So we are looking for how many coulombs of charge we're looking for. This comes down to our definition again of voltage. Voltage is the amount of energy or the change in energy per unit charge. If we're looking for charge, again, same thing I'm going to bring up, I brought up in the last question. I would maybe work with it in this format, get the Q out of the bottom of the fraction so that you are less likely to make an algebra mistake. Do realize that when you are doing the math with okay, I don't know if you can see that Java update available, but go away, please. Okay, now shoot, what was I even saying? When you're working with something and you have an answer in scientific notation, I'm just going to make up a number for an answer. It is definitely not the right answer. Please don't consider it to be the right answer. You should recognize that. It's Avogadro's number. If you want to enter a number like that in WebAssign, what you're going to do is enter that. Okay, the E takes the place of the times 10. All right, so if that's what's throwing you, there you go. All right, number 3. The current in a lightning bolt is 2 times 10 to the 5th amps, or, oh, yeah, 2 times 10 to the 5th amps. How many coulombs of charge pass through in 0.36 seconds? Okay, so the current we're being given, again, watch out for that scientific notation when you are entering your answers. And we want to know, we are given our time of in this case, 0.36 seconds. This is a pretty quick application of this one, right? So we're searching for the coulombs of charge on there. Should be able to get that pretty easily. Next, a resistor with a current of 3.5 amps flowing through. Okay, really tough to see here. All right, but my current, I'm going to guess that says 3.5 amps. Maybe it doesn't. Who knows? All right, converts. And then what's that number? Oh, heck, I don't know. I'm going to guess. I'm going to say that's what the number says on the top. If it doesn't, just, work with me here. All right, so it converts that many joules of electrical energy to heat energy. Then you're given a time of 7 seconds. What is the voltage across the resistor? Okay, well, if I'm looking for voltage, I'm probably going to need a voltage formula, right? Nope, that's not it. I was about to write down the current formula. That wouldn't help us very much now, would it? Okay, so there's my voltage formula. All right, what do I know? Let's think. I know my delta E for sure. Do I know the coulombs of charge? No, I don't. So I'm kind of a little bit stuck. But oh, look, I have this current thing going on. That's how many coulombs per unit time, and lo and behold, I know this one and I know this one, so I can solve for that one, and then I can put it over there. So it's a combination of the two formulas. That should help you out. Always start with what you know the most about, even if you're not sure where you're going with that. Okay, I think that pretty much takes us to electricity number 2. Oh, hairdryer current of 12.1 amps. How much charge? So for question A, I'm looking for coulombs of charge passing through the hairdryer in 3.5 minutes. You have to change that to seconds. And we've had a lot of conversations about converting. I like to use, if you cannot do this easily, the technique you learned in chemistry is really helpful, right? What you do is you set up a set of parentheses. Maybe they use straight lines, who knows? But the unit you want to cancel has to go opposite. The unit you want to solve for goes on the top. And then you ask yourself, well, how many seconds are in a minute? There are 60 seconds for every 1 minute. Therefore, I know I'm going to multiply these numbers together. If my 60 landed on the bottom for some reason, I divide. That way I don't have to think about it. I can just sort of, do it. And again, it's going to come in handy for part B. So you do this, right? And this is not necessarily the answer, but let's say that you get, I don't know, get like 50 coulombs of charge. Again, not the answer. Don't type that in. All right, you do the math, you get the real answer. But here's your coulombs of charge, and you want to know how many electrons does this represent? Well, let's change that to electrons. Again, coulombs has to go on the bottom because I want it to cancel out, right? And I'm going to have electrons on the top. The conversion factor is that 1 coulomb of charge has 1.6 times 10 to the negative 19th coulombs. Or I'm sorry, electrons, not coulombs. Let's change that. 19th electrons. So this number goes with the electron symbol on the top. 1 coulomb on the bottom. So I'm going to multiply those together. I'm still going to get a tiny answer. Please, please, please don't forget to do the exponent. Don't just drop it for no good reason. Cannot do that, people. Cannot do that. All right, let's see if I can get this to scroll. There we go. Next. Time to change colors. I'm getting a little sick of green. All right, nichrome wire with resistance of 20 ohms, and you've given 10.5 volt and current. Okay, this one's really easy. I'm not going to spend a lot of time here, right? You're given your resistance, you're given your voltage, you're asked to find your current. That is a straight application of Ohm's law. You should be able to find that with no trouble. Next. Another straight application of Ohm's law. We've got voltage, we've got current, we're asked for resistance. And so again, yeah, let's just apply that law, shall we? And figure things out. Calculate the current when it is connected to a 3-volt battery. Oh, this one's tricky. They put pictures of the resistors in there. Guess what, people? It's still an application of Ohm's law. No biggie. All right, let's see if we can get something a little more challenging here. Ooh, well, actually, didn't we have this kind of question before? I think we might have. This shouldn't be too tough, but it does get us out of VIR for a few seconds here, right? So we're being given our current, 2.1 times 10 to the 5th amps, and we're looking for coulombs of charge. Coulombs of charge is Q. All right, and we're given, again, our time, 0.55 seconds. This is another straight application of the current formula. All right, but we are solving for that piece. All right, let's see if I can scroll these a little more. Our last one here that we're going to take a look at. All right, we want to know the charge on the ion for this one, and we're being asked to find coulombs, so we're being asked to find Q. Okay, so what do we know? We know 70 volts. We know the amount of energy. I don't know what it says on here. I'm going to use the one that's on my paper because I can't read that at all. Way too tiny, even with my glasses on. Okay, this is an easy application of the voltage formula. Change in energy per coulomb of charge. Again, we are looking for what's on the bottom here, so don't forget to, get it out of that fraction form. It'll help you out. All right, so let's hope that this helps you out, and come and ask for questions if you need more.